Hello students, welcome to Siri Patshale. Today we shall start with problems based on Thales theorem or basic proportionality theorem. Yes, in the previous class we have discussed the theorem and yes, now what are the properties? Okay, what have we learned from this theorem? If a line is, if a parallel line is drawn to the to one of the side of a triangle, then that divides the other two sides into other two sides in equal proportion. That is the statement of basic proportionality theorem. If a line is parallel to one of the side of a triangle and that the end points of the parallel of that line intersects the other two sides in two distinct points, then the other two sides are divided in equal ratio or in proportion. That is a statement of basic proportionality theorem or Thales theorem. Okay. In today's class, let us discuss problems on Thales theorem or basic proportionality theorem from exercise 6.2. Okay, now let us start with the first main in exercise 6.2. Here some figures are given. Okay, some two figures are given. That is figure 6.17, and let me solve one of the problem in this main. Okay, so that is exercise 6. Exercise 6.2. In this first main, let me take first problem in this. Okay, figure is given. I mean a triangle is given here. Okay, and a triangle is given. Name of this triangle is ABC, and your line DE intersects AB at point D and AC at point E. Okay, these two are intersecting points. And some measurements are given. This is 1.5 centimeter. Which one? AD. Length of AD is 1.5 centimeter and length of DB is 3 centimeter. Then here AE is equal to 1 centimeter and EC is equal to how much we need to find. Find the length of EC. Okay. So this is the question. So here DE parallel to BC. What is given in triangle? In triangle ABC, DE parallel to BC, and given here AD and DB measures are given. AE is given. We need to find EC. EC how much it is. Okay. So based on the figure, what do you say now using Thales theorem? Here DE is a line parallel to BC, one of the side of the triangle ABC. Which are the other two sides? AB and AC. Since DE is parallel to BC, okay, what do you say about the sides? That is AD by write the reason by Thales theorem or basic proportionality theorem, BPT in short we can say, by BPT, basic proportionality theorem or Thales theorem. Thales theorem, we can say AD by DB is equal to AE by EC. So all these measures are given. Let us substitute. In place of AD, what should I write? 1.5. So this is equal to 1.5 centimeter. This implies 1.5 by 3.0 or 3 is equal to your 1 centimeter by, let us take EC as x or just just write EC. Okay. So how do you find now? Yes, you know how to solve this by cross multiplication. So 1.5 into EC is equal to 3 into 1. So this implies 1.5 EC is equal to 1 into 3, that is 3. So EC is equal to 3 by 1.5. How much it is? How many times it goes? 1.5 2 times. Okay, so 1.5 ones are 1.5 twos are. So length of EC how much? 2 centimeter. Okay, 2 centimeter. Okay, so this is the way you can find the answer. Okay, now let us go with second main. Okay, for second problem in this main. Okay, first main is also same type. You can do it easily. ಆರಾಮಾಗಿ ಮಾಡ್ಕೊಬಹುದು ಅದನ್ನ. ಇದೇ ತರ ರೇಷಿಯೋ ತಗೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ and cross multiply and solve it. Now second one, let us take now second main. E and F are points on the sides PQ and PR. Here also figure is given. Okay, E and F are points on the sides PQ and PR. PQR, PR respectively of a triangle PQR. Okay, is the figure related to that? No, that's different one. Okay, so we need to draw the figure for this. Okay, based on the given data, we have to draw the figure. E and F are points on the sides PQ and PR respectively of a triangle PQR. So basically, what do we need to draw? We need to draw a triangle PQR. Okay, so let us draw triangle PQR. Draw a triangle PQR. And what else is given? E and F are points on the sides PQ and PR. E ಮತ್ತೆ F ಯಾವುದರ ಮೇಲಿದೆ? PQ ಮತ್ತೆ PR ಮೇಲಿದೆ. PQ ಮೇಲೆ E respectively ಅಂದ್ರೆ ಈ PQ ಮೇಲೆ we have point E and PR ಮೇಲೆ we have point F. Okay, F. For each of the following cases, state whether EF parallel to QR. How do you say EF parallel to QR? Because you know basic proportionality theorem that says that if a line is parallel to the third side of a triangle, one of the side of a triangle, other two sides are divided in the equal ratio. That is the statement. But if that is true, its converse also must be true. No, viloma andre adu satya agirutte alva. Andre one line. So if I draw a line here EF, okay, if I draw a line EF or line segment EF, okay, then let us take the reverse viloma of this, okay, or converse of this statement, basic proportionality theorem. Basic proportionality theorem prakara or Thales theorem prakara, one line or line segment na one triangle na one side ge parallel agi samantarvagi helidre, okay, other two sides are divided ಅಂದ್ರೆ ಉಳಿದ ಎರಡು ಸೈಡ್ಗಳು ಅಂದ್ರೆ ಭಾಗಗಳು ಹಿಯರ್ ಅವರು ಕೂಡ ಈಕ್ವಲ್ ರೇಷಿಯೋದಲ್ಲಿ ಸೇಮ್ ರೇಷಿಯೋನಲ್ಲಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಟ್. ಓಕೆ, ಅದರ್ ಟು ಸೈಡ್ಸ್ ಆರ್ ಡಿವೈಡೆಡ್ ಇನ್ ದ ಸೇಮ್ ರೇಷಿಯೋ. ಓಕೆ, ಹಂಗಿದ್ಮೇಲೆ ಸಪೋಸ್ ಹಿಯರ್ ಟೂ ಲೈನ್ಸ್ ಆರ್ ಡಿವೈಡೆಡ್ ಇನ್ ಈಕ್ವಲ್ ರೇಷಿಯೋ. ಓಕೆ, ಈಕ್ವಲ್ ರೇಷಿಯೋ. then what do you say now? Opposite line should be parallel now. ಲೈನ್ ಪ್ಯಾರಲಲ್ ಇದ್ರೆ ಅದರ್ ಟೂ ಸೈಡ್ಸ್ ಈಕ್ವಲ್ ರೇಷಿಯೋ ಡಿವೈಡ್ ಆಗುತ್ತೆ ಅಂತ ಆದ್ರೆ, ಸಪೋಸ್ ಇನ್ ಅ ಟ್ರಯಾಂಗಲ್ ಟೂ ಸೈಡ್ಸ್ ಆರ್ ಡಿವೈಡೆಡ್ ಇನ್ ದ ಈಕ್ವಲ್ ರೇಷಿಯೋ ಅಂದ್ರೆ ಈಕ್ವಲ್ ರೇಷಿಯೋ ಡಿವೈಡ್ ಆಗಿದ್ರೆ ವಾಟ್ ಕ್ಯಾನ್ ಯು ಕನ್ಕ್ಲೂಡ್? ದ ಸೈಡ್ ದ ಲೈನ್ ಆರ್ ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ವಿಚ್ ಇಸ್ ಡಿವೈಡಿಂಗ್, ಓಕೆ, ದೋಸ್ ಟೂ ಸೈಡ್ಸ್ ಮಸ್ಟ್ ಬಿ ಪ್ಯಾರಲಲ್. ನೋ, ಪ್ಯಾರಲಲ್ ಆಗಿರ್ಲೇಬೇಕಲ್ವಾ? ಎಸ್, ದಟ್ ಈಸ್ ಕಾನ್ವರ್ಸ್ ಆಫ್ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಓಕೆ, ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಗಿವನ್ ಇನ್ ಯುವರ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್. ಕಾನ್ವರ್ಸ್ ಆಲ್ಸೋ ಗಿವನ್. ಇಟ್ ಇಸ್ Theorem 6.2. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That is converse of the statement, that is basic proportionality theorem or Thales theorem. Okay, so if a line divides, same theorem we apply here now. Okay, if a line divides any two sides, here PQ and PQPR are divided in the same ratio. Okay, in the same ratio, then what do you say? The line is parallel to other side or parallel to third side of the triangle. Okay. So let us use this now in exercise 2.6.2 second main. So here what are given? Now given is first one, let me take, it is given EPE, given PE is equal to 3.9 centimeter and EQ 3 centimeter. Then PF 3.6 centimeter, PF 3.6 centimeter and FR it is 2.4 centimeter. Okay. So what do we need to prove now? Prove madbekirodeniga. We need to prove these ratios are equal. Okay, ratio of the sides are equal. Okay, if they are equal, what do you say? Line is parallel, isn't it? Okay, so to prove, what to prove? EF is parallel to QR. EF is parallel to QR. Okay. Now let us take the ratio of the sides. Okay, let us find it now. First let us take PE by EQ. Let us take now one of the ratio. PE, proof. PE by using the given measure, let me find the ratio now. PE by EQ, how much? PE how much? 3.9 centimeter by EQ how much? 3 centimeter. Okay, 3.9 by 3. Can we simplify this? Yes, 3 ones are 3, 1.3. 3 ones are 3, 3 threes are 9. So 1.3 by 1 or 1.3. Okay, 1.3, that is the ratio of this. Now let us take other one. It is PF and FR. So PF by FR is equal to PF how much? Is 3.6 centimeter by FR 2.4 centimeter. Okay, 3.6 by 2.4. Let us simplify this also. Which table can be used? We can use 2 plus 4, 6, 3 plus 6, 9. Okay, so we can use 3 ones a table, or 12 twos are 24, 12 threes are 36. We can use 12 ones are also. So let us take 0.2, that is by here 12 threes are. Okay, 12 twos are 12 threes are. Okay, so this is nothing but what? 0.3 by 0.2. If you multiply both these sides by 10 to get a whole number, what do we get? It is equal to 3 by 2. It is 0.3 into 10 by 0.2 into 10. What do we get? We get 3 by 2. Here we have 1 by 1.3. Here we have 3 by 2. Are they equal? 1.3 and 3 by 2? No, they are not equal. Okay. So what do you say? The sides EF and QR are not parallel. That is the question. Okay, so we have proved. Okay, state whether, we have to check in the question whether EF is parallel to QR. No, they are not parallel. Okay, so what do you say now? As the ratios PE by EQ is not equal to PF by FR, what do you say? EF is not parallel to QR, or EF and QR are not parallel. This is the way you can find whether the lines are parallel or not. Okay, so using the converse of basic proportionality theorem. Now let us go with third problem, third main. Okay, if you can do two more sums are given here. Okay, ಒಂದೇ ತರ ಇನ್ನೆರಡು problems ಇದೆ, ಅದನ್ನು ಇದೇ ತರ ಮಾಡಿಕೊಂಡು prove ಮಾಡಿ. Okay, now let us take third one, third main. Third main. Figure 6.18, okay, which is 6.18. Let me draw now. This is a triangle. We have this figure A, B, C, D, and here there is a point L. There is a point L. Okay, and here these two points are M and N. M and N. The question is, in figure 6.22, this is the figure given. Okay. LM is parallel to CB. Which is LM? This is. Okay, this is parallel to CB. And LN is parallel to CD or DC. Okay. Prove that AM by AB is equal to what? AN by AD. Okay, is it exactly basic proportionality theorem? No. Okay. So let us prove this now. Okay, so what is given? You write now. Given in the given figure or in figure, what is given? Always to write given is very easy. Question ಏನು ಕೊಟ್ಟಿರ್ತಾರೋ ಅದನ್ನು ಬರಿತೀವಿ. Okay, along with the figure. And drawing figure is also very important. Okay, when you have this type of problems, any figure based question ಕೊಟ್ರೆ figure draw ಮಾಡಿನೇ answer ಮಾಡಬೇಕಾಗುತ್ತೆ. Okay, so here LM is parallel to CB. LM is parallel to CB and LN is parallel to CD. Okay, CD, this is given. What to prove? We need to prove AM by AB is equal to AN by AD. AN by AD. Okay. So these are from the figure. Okay, what is given and what is to be proved. Okay, now let us go with the problem. How to prove this now? According to BPT, basic proportionality theorem or Thales theorem, what do you say now by the figure? It is given that LM is parallel to BC. So let us consider the first triangle. This is the first triangle. Okay. So in this triangle, LM is parallel to BC. Then how do you write the ratios of the sides now? AM by MB is equal to AL by LC. Okay. Right. Proof. Okay. According to BPT, basic proportionality theorem, we write AM by MB is equal to AL by LC. LC. Let us take another triangle. This second triangle. In this triangle, okay, so here which is parallel? LN is parallel to CD. So what do you say about the side? Here AN by ND is equal to AL by LC. This is equation 1, and let us take AN by ND or DN, ND or DN is equal to that is AL by LC. Now see both the equations. What do you observe? In both the equations, RHS is equal, isn't it? RHS is same. Here also we have AL by LC. Here also AL by LC. RHS is equal. Same is the RHS eradu kade. So what do you say? RHS same idmele LHS must be equal, alva? Okay. So 2 plus 4 is equal to 6 adre. Okay, then 3 plus 3 is also is equal to 6. So 6. Right hand side equal. So what do you say LHS? 2 plus 4 is equal to 3 plus 3. So similarly, here RHS is equal. So what do you say? LHS is also equal. So right now, by equations 1 and 2, what do you say? Here AM by MB is equal to MB is equal to AM by MB is equal to AN by ND. AN by ND. Now, is the theorem statement proved? No, because we need AM by AB and here AN by AD. See the numerators, we have equal. Okay, illu AM ide, allu AM ide. Illi second RHS AN ide, here also we have AN. But here the denominator part, we have to bring the whole AD, isn't it? AB and AD must be there. Adun taroke ಏನು ಮಾಡ್ಕೊಬೇಕಾಗುತ್ತೆ? We have to think now. Okay. So whole ಅಂದ್ರೆ ಏನಿರುತ್ತೆ actually? Sum of this part, AN and ND, isn't it? Okay. Illu whole AB ಅಂದ್ರೆ ಏನಗ? AM plus MB, that is equal to AB. So we should get that form now. How to get? Now let us write a reciprocal of this. Okay. If suppose here 1 by 2, 1 is to 2, 1 by 2 is equal to 2 by 4 idre, 2 by 1 is equal to what? 4 by 2, correct? No? Okay, 1 by 2. Here 2 ones are, 2 twos are. Here also what do we get? 2 ones are, 2 twos are. 2 by 2 is equal to 2. So their reciprocals are also equal. So let us write the reciprocal of this now. So this implies, I erase this given part. Okay. This implies, by this I am getting now, this implies MB by AM is equal to ND by AN. ND by AN. Okay, now let us add 1 to both LHS and RHS by adding. So suppose here when we have two ratios or two fractions, any number, if you add or subtract, if you do the that operation on both the sides, okay, result remains unchanged. Okay, suppose 1 add ಮಾಡಿದ್ರೆ ಎರಡು ಕಡೆ add ಮಾಡಿದಾಗ result change ಆಗಲ್ಲ ಅಲ್ಲಿ. Okay, ಅದೇ ತರ any one ಅಥವಾ ಯಾವುದೇ ನಂಬರ್ ನ subtract ಮಾಡಿದ್ರು ಎರಡು ಕಡೆ result change ಆಗಲ್ಲ. So I will add 1 to both LHS and RHS. So let me write MB by AM plus 1 to LHS is equal to ND by AN plus 1 to RHS also. Okay, so result remains unchanged. So what to do now? AM when you take LCM, this is 1 means 1 by 1. Illu 1 andre 1 by 1. Okay, LCM tagondu add madre enagutte. So here AM is common denominator LCM. So AM has to be multiplied for 1 by 1, isn't it? So it is equal to MB plus AM by AM. Okay, so this is the MB plus AM. This is 1 by 1. I multiplied for both numerator and denominator by AM. Okay, to get common denominator as AM. Illi RHS kuda, yes, AM is common denominator. So I multiply both the numerator and denominator by AM. Okay, so what do I get now here? ND plus AN by AN. By AN. Now you got to know why I have taken the reciprocal here. Okay. So, see the figure, MB plus AM. What do we get? We get AB. Here also, it's again ND plus AN. What do we get? AD. Okay, so in place of MB plus AM, I will write AB now. This implies AB by in denominator, what do we have? AM is equal to, here ND plus AN is nothing but AD by AN. Now, what is the result we need to prove? AM by AB is equal to AN by AD. So what should we do? Should we take now? We have to take the reciprocal of this. Vilomana tagonbeku matte. So viloma tagondre or reciprocal tagondre, we get AM by AB is equal to AN by AD. AN by AD. So hence proved. Hence proved. Hence proved. Okay. Next problem. Let us go with the fourth main first one. So the important problem, fourth main first one. Copy this now. Fourth main important problem. Actually, by seeing the figure, you feel it is difficult one, but it is very simple. Okay, figure nodale nimage kashta ansutte, adre idu kashta illa, tumba sulabhavada problem. So let us draw the figure. Draw the figure. One triangle is given. ABC is a triangle. ABC is a triangle. ABC and D and F, the points D and F. This DF is parallel to AC, and one more AE. A and here we have a point on the line, and it is joined A, point E, and this is point D and F, and DE is also joined. DE is also joined. What is given in the question? DE parallel to AC. Which one? This one. DE parallel to AC. It is given. And another one, DF parallel to AE. DF parallel to AE. DF parallel to AE. Another set of parallel lines. Okay. So let us write now given is in triangle ABC, or just you can write in the given figure, that also fine. What is given? DF parallel to AC and DE parallel to which one? AC, and DF parallel to AE. Okay. Prove that. What is to be proved? To prove BF by FE is equal to BE by EC. Okay. So this has to be proved. Okay. BF by FE. So as soon as you get the question, you check which triangle contains these two sides. Yav triangle alli ee part ide nodಕೊಳ್ಳಿ. BF and FE. BF and FE. Okay, so which is the triangle? ABE is the triangle. Okay, see the next one. BE and EC. Where are they? BE, EC. So which is the triangle? Triangle is ABC. Okay, ಇದು ನೋಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ನಿಮಗೆ you can easily use basic proportionality theorem. Okay. So let us take the first triangle. Which one? ABE. In triangle ABE, proof. In triangle ABE, which are parallel sides? DF and AE. DF parallel to AE. So how do you write the ratios of these sides? It is BF by FE, BF by FE is equal to which is the other side? BD and AD or DA. BD by DA. This is one side. Let us consider this as equation 1. Now take the other triangle. Other triangle which contains which one? BE by AC. BE and AC. How triangle is there? Check that. So BE and EC are in the triangle ABC. So right now in triangle ABC, which are parallel sides to say they are equal? Here in triangle ABC, here DE parallel to AC. DE parallel to AC. So how do you write the ratio? BE by EC, which implies BE by EC is equal to, yes, other side. See, BE by EC. Then which is the other side? Here BD by DA. See, that's why put different colors. ಬೇರೆ color ಹಾಕಿದ್ದೀನಿ. See, ADE ಮತ್ತೆ ACR parallels. Orange color ಹಾಕಿರೋದು. Okay. So which are the segments? BD and DA. Okay, BD and DA. So what do you observe now? See, both the equations. ಇಲ್ಲಿ ಕೂಡ RHS ಇದೆ BD by DA. ಇಲ್ಲಿ ಕೂಡ RHS BD by DA. So what do you say about LHS? LHS are also equal. RHS equal idre obviously LHS must be equal. Okay, so what do you say now? By 1 and 2, by 1 and 2, we can say BF by, that is LHS of first equation FE is equal to LHS of second equation is BE by EC. Very simple. Hence proved. Right now. Hence proved. proved. Hence proved. ಸಾಧಿಸಲಾಗಿದೆ. Okay, so now let us go with another problem. It is problem number 5. Okay, this is also one of the very important problem, fifth one. Okay, so finish this now. Okay, now fifth problem. I just explained this problem because fourth and fifth both are of same kind. ಒಂದೇ ತರ ಇದೆ, ಏನು ಡಿಫರೆನ್ಸ್ ಇಲ್ಲ ಅಂತದ್ದು. So fifth problem, diagram is given. Is a triangle and here there is a point. Okay, and there is a parallel line. Okay, this is the figure. Figure ನೋಡಿದ್ರೆ ಯಪ್ಪ ಎಷ್ಟು ಕಷ್ಟ ಅನ್ಸುತ್ತೆ, ಇಲ್ಲ ಬಟ್ ತುಂಬಾ ಈಸಿ ಇದೆ ಸಮ್ ಕೂಡ. Okay, that is P Q R is a triangle and what is given? DE parallel to OQ. ಯಾವುದು DE? First let us name it. P, this EF and here this point is D and this point is O. Okay. So given DE parallel to OQ, which is DE, this one, this DE parallel to OQ. Okay, these two are parallel lines. Next, DF parallel to OR, which is DF, this one, DF parallel to OR. Okay, one more set of parallel lines. Show that EF parallel to QR. EF parallel to QR. So we need to prove EF parallel to QR. That means what? Converse of BPT, converse of Thales theorem. Okay. So what do you do now? To prove converse of Thales theorem, what do we need? We need to first find whether the ratios are equal. So our work is now to prove the ratios are equal. How do you prove now? So take the triangle, which one? POQ. Okay, POQ. Since they have given, avare kottbididare alli ee two lines parallel ide anta. So what do you say? PE by EQ is equal to PD by DO. In another triangle, okay, they have given DF is parallel to OR anta kottidare. So what do you write? PF by FR is equal to PD by DO. ಹಿಂಗೆ ಅವಾಗ ಬಂದಂಗೆ two equations ಬರುತ್ತೆ. So here also this is common. OD by the PD by ODO is common in both. ಅಲ್ವಾ? RHS ಎರಡು ಕಡೆ ಈಕ್ವಲ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಅವಾಗ we can write PE by EQ is equal to what? PF by FR. So what do you say? Obviously converse. Okay, if the ratio sides are divided in the same ratio, lines are parallel. Okay, sides ಬಂದ್ಬಿಡುತ್ತೆ equal ratio ಅಂತ. Equal ratio ಬಂದ್ಮೇಲೆ ಏನು ಹೇಳ್ತೀರಾ? You can say, okay, EF is parallel to QR, hence proved. Okay, using converse of BPT. Okay, or theorem 2 in this chapter. Okay, now let us go with the sixth problem. One of the important problem. Sixth problem. Sixth one. Problem is in figure 6.21, a figure is given. A, B and C are points on OP, OQ and OR respectively. Yes. Such that AB parallel to PQ and AC parallel to PR, and you have to show that BC parallel to QR. Okay, so let us draw the figure first. This is problem number 6. Okay, 6. Let us draw the figure 6.21. It is triangle PQR. PQR, and here one more triangle inside a triangle. There is a point. Okay, one. This point is O. Okay, then B is point B is on OQ, and point C is on OR. Let us join OC, and one more, join PO also, and point A is on the line PO. This is point A. Okay, so ABC are joined to get a triangle ABC. Okay, so this is triangle ABC. So this is the figure. Okay, so here they have given AB and CR. What are given, you write. Okay, in given part you can write. That is given in the given figure. In the given figure or figure A and B. Okay, A, B and C are the points on PO or OP, right, as it is in the textbook. It's easy to understand. OP, OR, OQ and OR. OQ and OR respectively. And what else is given? AB parallel to PQ. Which is AB? AB is parallel to PQ. It is given. And one more set, which is that AC parallel to PR. Okay, these two are parallel lines. Okay, AB parallel to PQ and AC parallel to PR. Okay, this is given in the question. Now what is to be proved? To prove BC parallel to QR. To prove BC parallel to QR. Which is BC? BC parallel to QR. Yes. How do you prove this now? Yes. We have to first you see here BC and QR are in which triangle? Okay, which one? OQR. Okay, BC line BC is in the triangle OQR. This triangle is there. Okay, so let us take other two triangles. Which are other two triangles? Here POQ one triangle, POR another triangle. Now in POQ, okay, AB is parallel to PQ. Then what do you write? The ratio OA by AP is equal to OB by OK. ಆಗಿರುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಟ್ರಯಾಂಗಲ್ ಅಲ್ಲಿ. It is OC by CR is equal to OA by AP. So which is common? OA by AP is common. Okay. Then if they get cancelled, we write LHS. What do we write? OB by OBQ is equal to OC by CR. Then what do you say? Ratios of the sides of the triangle OQR is equal. If the ratios are equal, what do you say? BC is parallel to QR. Very simple. Okay. So let us take the first triangle, which is which one? POQ. In triangle POQ. In triangle POQ. Now, in triangle POQ, let us write which are parallel sides. AB parallel to PQ, AB parallel to PQ. This implies OB by OQ is equal to OP by OA by AP. Equation 1. So second one, in triangle, which is the other triangle, other side with orange mark, POR. In triangle POR, parallel sides are AC and PR. So what do you say about the ratio? OC by CR. This implies OC by CR is equal to OA by AP. Compare 1 and 2. RHS is equal. So LHS also must be equal. Comparing 1 and 2 or by equation 1 and 2. Comparing 1 and 2. We can write OB by LHS. OB by OQ. OB by OQ is equal to OC by CR. OB by OQ by is equal to OC by CR. These are the sides, okay. This side OQ is divided into OB and OQ. Here in this triangle, OC is and CR are the parts of the side OR. So what do you say? This implies BC parallel to QR. BC parallel to QR. What is the reason you write? If that is converse of BPT, right? Reason converse of BPT, or you can write the statement also. Converse of BPT. Okay, hence proved. What is the statement of converse of BPT? Hence proved. Hence proved. What is the concept of BPT? Viloma. BPT Viloma is if a line divides two sides of a triangle in same ratio, the line is parallel to the third side. That is converse of BPT. Here, this line, which one? BC divided OQ and OR in the ratio. That is OB by OQ is equal to OC by CR in proportion or in the same ratio. So what do you say? These two sides, which one here? BC, these two lines BC and QR are parallel to each other. Okay, converse. So here we have proved this also. Very simple now. So last, we'll do some more problems in the next class. This. So let us end today's session. Thanks for joining and bye-bye.